In this lab, we will look at the data collected for price index and will carry out the data analysis. The price of eggs has fluctuated in recent years. The table below shows some prices charged by Mrs. Hampshire for her large eggs and also the quarterly food price index. So we have the quarters June 1999, September 1999, December 99, March 2000, June 2000, and September 2000. The price of the large eggs in dollars and cents is for June $73, for September $72, for December $72, for 2000 March $75, June 2000 $76, and September 2000 $77. It has been increasing. Quarterly food price index for June 1999 is 1000, September 99 is 994, December 99 is 990, March 2000 is 1004, June 2000 is 1000, September 2000 is 1012. Price with if Mrs. Hampshire was to have adjusted her prices to keep pace with food price inflation, what should she have changed in December 1999? Use June 1999 as the base. So June 99 is the base. So price with June 99 in dollars and cents. For June 99, the price of the eggs remains same, which is $73. If Mrs. Hampshire was to have adjusted her prices to keep pace with food price inflation, what should she have changed in December 1999? So let's find price with the base June 1999. So that equals the food price index divided by the food price index for June 1999 multiplied by the price with base June 1999 and round it off to 2 decimal place, and we do the same to all other prices. So for December 1999, it's $71. So Mrs. Hampshire should have charged $71 in December 1999, but she charged $72. Express the September 2000 price in June 1999 dollars. So September 2000 price is $75, which we have found. So this is equal to the quarterly food price index for September 2000 divided by the base quarterly food price index for June 1999 multiplied by the price with June 1999 dollars and cents. So and then round it off to 2 decimal place, and that's $75. But Mrs. Hampshire charged $77. Okay, let's plot this graph with the price with June. So let's click on Insert, click on Chart. Let's take the chart to the own sheet. Let's edit the chart, and that will be a line chart. add the range. So all the quarters, and then add another range, price with June 1999 as the base. Let's customize. For the vertical axis, let's change the minimum value 1.5. We can 1.7. Okay, so what about the price that was actually charged? So on the chart, let's add another data range for the actual price being charged. Let's add it to the series. Okay, so the actual price was bit higher from September 1999 and onwards, and the price with June 1999 as the base was lower from September 1999. Change all the egg price index with June 1999 equal 1000. Use this to discuss. So change all the egg price index with June 1999 equal 1000. So we want to change the egg price index June 1999 equal 1000. So what we do, the price of the egg for the quarters divided by the price of the egg in June 1999 multiplied by the quarterly egg price index for June 1999, that's 1000, and we round it off to the whole number, and we do the same for all other cells. And let's plot this on the chart. So we add the data range. That's a quarterly egg price index. And let's add it to the series. Let's remove the prices. Let's also add the given quarterly food price index, quarterly food price index. So let's add it to the series. Let's customize the vertical axis. So we want to change the minimum value. Let's change it to 900. Let's change it to 975. Let's change it to 980. Okay. So the quarterly food price index, which is in red, and the quarterly egg price index is in blue. So what's the question? Change all the egg price index with June 1999 equal 1000. Use this to discuss whether Mrs. Hampshire's pricing policy for her large eggs is in line with the price of other food items. From the chart, we can see that it's not in line after September 1999. Food prices increased 1.2%. So that is the 1.2% is coming from equal 1012 minus 1000. So 12 that will be 12 divided by 1000 multiplied by 100, and that's 1.2%. So the quarterly food price index increased by 1.2%, and the quarterly egg price index increased by so from 1000 it increased to 1023. So there was increase of 23 units divided by 1000 multiplied by 100, and that's 2.3% increase. Her egg prices increased 2.3%. Let's look at consumer price index. The consumer price index is updated from time to time. The current series is June 1999 equal 1000. June 1999 equal 1000. The previous base period was December 1993. The table shows some of the values. So quarters are given. The first column, and then the column for December 1993 equal 1000 has the base, and some of the values are given. And for June 1999 equal 1000, some of the values are given. What is the unusual feature of the CPI? So let's plot these values. So let's insert a line chart. Let's take this chart to on sheet, edit chart. For we want line chart. And add the range, all the quarters, and then we want December 1993 equal 1000 base values, and add another range with June 1999 equal 1000. Okay, so let's customize a vertical axis. We want a minimum value of the vertical axis to be 1000, say 1075. Okay, now let's go back to the question. So what is the unusual feature of the CPI from September 1998 to March 1999? So September 1998 to March 1999. So there was a decrease. The CPI is decreasing, so prices are dropping. Calculate PQR, the CPIs for September 98, December 98, and March 99. For June, for the base, June 99 equal 1000. So we want to calculate PQR, and P equal to June 1999 is the base, equal to the December 1993 equal 1000 has the base value, the value divided by the June 99 base value multiplied by the new CPI for June 99 has the June 99 equal 1000. And we round this off, and we'll do the same for all other cells. So let's put the $sign for the cell location. So we'll do the same for PQR. So P equal 1009, Q equal 1001, and R equal 998. And we'll copy this. We'll do the same upwards as well. So Control C and paste it. Okay. And we'll do the same for S as well. So we'll put these three values PQR in bold and the S in bold. Okay, if inflation for the March quarter of 2000 is 2%, calculate S, the new CPI. So the inflation for March quarter is 2%. So, okay, so this value for March quarter that was marked as, let's find that. So if the inflation was 2%, so which means that this S value minus this value the June 1999 has the base value minus 1000, divide by 1000, multiplied by 100 gave us 2%. So what we will do to find the value for S, we will multiply 2 by 100 we will divide 2 by 100 and then multiply by 1000 and then we will add 1000. And that's 1020. So the value for if inflation for the March quarter of 2000 is 2%, calculate S, the new CPI. Oh, okay. So what happens is that for the March quota, so from the starting up to March, so uh, times 99 plus 999. Okay. And sorry. So the inflation for March quota of 2000 is 2%, calculate as the new CPI. So it's looking at from December 1999 to March 2000. So that is equal to 2%, we change it to decimal 0.02, then multiply by 1006 and then add 1006 and round it off to a whole number. 1026. So let's look at the chart. Let's plot that series. Let's delete the chart and redo it. So let's insert the line chart. Let's select the data range. And then let's add another data range. Let's add another data range. Okay. Let's change the vertical axis minimum value. Okay, so the blue line is for December 93 as the base, and the red line is um, the June 1999 as the base. Let's remove the series for December 93. Okay, so we only have for June 1999 equal 1000. Let's customize the vertical axis minimum value. Okay, so now the inflation, so it says if inflation for March quota of 2000 is 2%, calculate as the new CPI. So it's not 1006, but it will be a inflation. So equal 2%, we change it to decimal number 0.02. Then we multiply by the December 1999 quarter, and then we add it to December 1999 quarter, and then we round it off to whole number. That's 1026. Let's look at the chart. Should have picked it up. Yeah. So for December 1999, and from December 1999 to March 2000, there was a inflation of 2%. Now let's look at salaries of secondary teachers data. Salaries of secondary school teachers are renegotiated periodically. The salary for a teacher at the top of the teachers scale are below. So quota June 91, salary 41,039. Quota June 96, salary 45,000. March 97, salary $47,100. And for quota March 1999, salary is $48,600. The CPI for December 93 equal 1000 is 971. For June 91. For June 96 is 1071. For March 97 is 1082. And for March 1999 is 1095. So the salary and the CPI is increasing. Now express all the salaries in constant June $91. So June $91. Salaries in June $91, that will remain same, 41,039. And we need to express all other salaries. For June 96, it will be equal to the CPI for June 96 divided by the CPI for June 91 multiply by the salary for June 91. Multiply by okay, so that equals the CPI for June 91 divided by the CPI for June 96 multiplied by the salary for June 96. Yeah, and then we'll round it off to the whole number. And we do the same to the rest of the cells. So we divide the CPI for June 91 by the sales CPI, quarterly CPI. So we put the constant dollar, and that's 40,798. Let's calculate for the rest of the cell. So express all the salaries in constant June $91. Let's plot this. So let's click on insert, click on chart. Let's move to the chart to its own sheet. For the chart type, click on line chart. For the data range, let's select the data range, quarters, and let's add salary that was given, and let's add the salaries in June $91. Okay, so let's customize the vertical axis. for the minimum value, let's put 30,000, say 35,000. Say 40,000. Okay, so the blue line shows the salary that was given, and the red line shows salary in June, $91. What conclusions do you come to about the earning power of teachers over this period of time? They were worse off in June 96. So June 96, the salaries in June $91 was worse, was the lowest. But from then on have been better off. The salaries have been increasing from then on.